Welcome to the Level 2 video on differentiation and integration. Today we're going to start off by talking about the product rule. And the product rule says that if y is equal to the product of two functions, u and v, then the derivative of y with respect to x is u times dv by dx plus v times du by dx. Okay, and let's jump straight in and look at an example of this. Calculate the derivative of y equals x squared times sine of 2x. Okay, and our solution is going to be the following. So the first thing I want to do is identify u is equal to x squared and v is going to be equal to sine of 2x. So we substitute these into the formula. So then we need to calculate du by dx, which is 2x, and dv by dx, which is 2 cos of 2x. Then dy by dx is x squared times 2 cos of 2x plus sine of 2x times 2x. Simplifying this gives us 2x squared cos of 2x plus 2x sine of 2x. And you can always factorize it out, but we're just going to leave it like this. And now let's not talk about the product rule anymore, let's talk about the quotient rule. And the quotient rule says that if y is now the quotient of two functions, u over v, then the derivative of y with respect to x is v times du by dx minus u times dv by dx all over v squared. All over v squared. And let's jump straight in and have a look at an example of the quotient rule. Calculate the derivative of y equals cos of x over x squared. And our solution is we have to identify u to be cos of x and v to be x squared, then calculate du by dx, and that's minus sine of x, and we need to calculate dv by dx, which is just 2x, then dy by dx is minus x squared sine of x minus cos of x times 2x, all divided by x to the 4. Simplifying this, taking the minus out the front, we've got x sine of x plus 2 cos of x all over x cubed. And that's the final answer. Then the last topic we're going to talk about today is implicit differentiation. And if we consider the equation x squared plus y squared minus 1 equals 0, this is the equation of a circle, then let's look at the following statement. So this is an example of an implicit equation, as y is not written explicitly as functions of x. And what this means is that we can't differentiate this normally. So if we want to calculate the derivative of this, we can start differentiating as normal, so x squared differentiates to 2x, but when we differentiate a y, we differentiate this normally, but then we times by dy by dx. Minus 1 differentiates to 0, and left with 0. But then we need to rearrange this for dy by dx. So dy by dx is minus x over y. Thanks very much for listening.